expect to experience brain fog, and therefore believe they are actually affected. Others argue that the mental symptoms might simply be too difficult to confirm in a laboratory setting. In the most recent study, researchers at Brigham Young University gave cognitive and neuropsychological tests to 21 women in their third trimester of pregnancy and then tested them again 6 months after they gave birth. They administered the same tests at similar intervals to 21 women who had never been pregnant. They found no differences between the groups, no matter when they were tested, including before and after giving birth. These findings mesh with those from a 2003 study, which found that pregnant women did not score differently from non-pregnant women on tests of verbal memory, divided attention, and focused attention. There is variety in the results, but overall, most studies suggest there are few to no memory impairments associated with pregnancy, says Michael Larson, a psychologist at Brigham Young and a co-author of the recent paper. He thinks the reason the myth persists may be that women selectively look for evidence that supports the cultural expectation. For example, when a pregnant woman loses her car keys, she might blame pregnancy brain, without recalling the times she lost her car keys before she was pregnant. Joanna Workman, a psychologist at the University of Albany, agrees that confirmation bias may play a role. But she says there is another possibility, too. In a 2011 study, a team at the University of British Columbia found that although pregnant women did not display any problems on cognitive tests given in a lab, they were less likely than non-pregnant women to remember to call the lab when asked and to return a questionnaire on time. It's possible that lab-based measures do not reveal differences, because labs are typically quiet environments with minimal distractions, in contrast with everyday life, she says. Melinda Wenner Moyer. Originally published, Scientific American Mind, 26, Volume 5, 10, September, October, 2015. 5 Common Myths About the Brain, by the editors. Myth: humans use only 10% of their brains. Fact: the 10% myth, sometimes elevated to 20, is mere urban legend, one perpetrated by the plot of the 2011 movie Limitless, which pivoted around a wonder drug that endowed the protagonist with prodigious memory and analytical powers. In the classroom, teachers may entreat students to try harder, but doing so will not light up unused neural circuits. Academic achievement does not improve by simply turning up a neural volume switch. Myth: left brain and right brain people differ. Fact: the contention that we have a rational left brain and an intuitive, artistic right side is fable. Humans use both hemispheres of the brain for all cognitive functions. The left brain, right brain notion originated from the realization that many, though not all, people process language more in the left hemisphere and spatial abilities and emotional expression more in the right. Psychologists have used the idea to explain distinctions between different personality types. In education, programs emerged that advocated less reliance on rational left brain activities. Brain imaging studies show no evidence of the right hemisphere as a locus of creativity, and the brain recruits both left and right sides for both reading and math. Myth: you must speak one language before learning another. Fact: children who learn English at the same time as they learn French do not confuse one language with the other, and so develop more slowly. This idea of interfering languages suggests that different areas of the brain compete for resources. In reality, young children who learn 2 languages, even at the same time, gain better generalized knowledge of language structure as a whole. Myth: brains of males and females differ in ways that dictate learning abilities. Fact: differences do exist in the brains of males and females, and the distinctive physiology may result in differences in the way their brains function. No research, though, has demonstrated gender-specific differences in how networks of neurons become connected when we learn new skills.